Hello, this is Mr. Wakefield here, and what we're going to be doing here as we are in our current module of learning how to solve polynomial equations is that it's important that we first of all be able to recognize which equation is which. In other words, which type of equation do we have in each situation. We're going to be learning about solving linear equations, quadratic equations, and also higher order polynomial equations. Each one of them is going to have a different method. In fact, the quadratic equations will have multiple methods. But in order to be able to know which method to choose, you got to be able to know whether or not you have a linear equation, a quadratic equation, or a higher order polynomial equation. So we're going to talk about that right now, and then later on we'll learn about the methods that we use to solve them. So today what I'm going to do right here is I'm not going to solve these equations. Again, we'll learn about the methods for solving coming up. But what we're going to do right now is just be able to make sure that we can recognize which equation is which type is each one of these. So let's get started here with the first one. Notice here that there's a difference between this one, and this one. We'll get to this one here. This one's a little bit different. We'll get to that in a minute. But the difference is that, yes, both sides of the equal sign are polynomials on all three of these that I just pointed at here. All three of them are. But the difference is the exponents, okay, that are attached to the variable. Notice here that in this problem, the highest exponent that you have attached to the variable is 1, because you have x to the first, x to the first, x to the first, and x to the first. So the biggest one is x to the first. Here you have x to the second and x to the first. So the biggest one is x to the second. And finally over here, the biggest one that you have is x to the third, because you have x to the third, x to the second, and x to the first. Okay, so here's how it works. If the highest exponent attached to the variable is 1, assuming that there's a polynomial on each side, which there is, as you can see there, this is called a linear equation when that happens. Okay. When you have a polynomial on each side, like we again do here, but the highest exponent attached to the variable is 2, that is called a quadratic equation. Okay, and finally, when the highest exponent attached to the variable, again, assuming you have a polynomial on both sides, is 3 or higher, okay? In this case, it's 3. You could sometimes see 4. In that case, that's called a higher order polynomial equation, okay? So then what does that mean for this last one here? Well, this last one, when you first look at it, you're thinking to yourself, hey, wait a second, that looks linear because I only see x to the first and x to the first, just like over here. But remember what I said. I said that figuring out what the highest exponent is attached to the variable, that's upon the assumption that you have a polynomial on each side. When you have the parentheses with something multiplied by it there, that's not a polynomial yet. You can make it into one, though, by distributing out the x here. Okay, x times x is x to the second. X times -1 is negative x. Now it's a polynomial on both sides. And what does it look like? Does it look linear, quadratic, or higher order? Well, I think you can see here that because the highest exponent is 2, it's a lot like this one. And indeed, because the highest exponent is 2, that is also a quadratic equation. And so now we can see how to recognize the different types of polynomial equations that we're going to see. And so moving forward now, we will, in future lessons, talk about the methods for solving each one of these 3 different types. But again, it's so important that we know how to recognize each type of these equations so that we'll know which method to use. Okay, so you take care, and we'll see you back for that next lesson coming up in the module.